All right, this video we're going to take a look at another example of solving exponential equations, and we're going to use something related to the formula for radioactive decay that we looked at in the last video, and that's called Newton's law of cooling, named after Sir Isaac Newton, for the temperature of an object placed in a surrounding medium. So it's going to look at how the temperature of something is affected by time and the temperature it was at the start and the temperature of the air around it. So typically like a room temperature, maybe an oven if you're cooking something, or a refrigerator or freezer if you're keeping it cold. So we had in the last video, A of t equals our initial amount times e to the negative kt. And Newton's law of cooling, here's our e to the negative kt, but there's a little bit of some extra stuff going on here. And here, we're going to look at the temperature of an object, and we typically use a capital T for temperature and a lowercase t for time. So our temperature of an object based on the time is T sub s plus the difference between T sub 0, our initial temperature, and T sub s. T sub s is the surrounding medium temperature, and then that's times e to the negative kt. So once again, T of 0 is the initial temperature, T sub 0, of the object. T of s is the temperature of the surrounding medium, say a room temperature, or maybe the temperature of an oven, or a pot of boiling water, or whatever the case may be. And K, once again, is our constant of proportionality. And much like in the last video, we're going to find the value of K first. So a little bit of what we did in the last one, just with some extra stuff going on around this e to the negative kt. So example 3, a 40-degree roast is cooked in a 350-degree oven. After 2 hours, the temperature of the roast is 125 degrees, which for me would be just fine, but I understand some people want their food cooked a little longer. And so part A, we're going to assume that the temperature of the roast follows Newton's law of cooling. Find a formula for the temperature of the roast, T, as a function of its time in the oven, lowercase t in hours, round to 4 decimal places. So much like we did with the iodine 131 example, we're going to create a function which then we can use to answer questions about figuring out the temperature knowing the time, or figuring out the time knowing the temperature. So here's our equation, and it tells us that the roast was 40 degrees when it was put in this 350 degree oven. So our initial temperature of the roast is 40 degrees, and the temperature of the oven is 350 degrees. Now, after 2 hours, so when lowercase t here in the exponent, when this is equal to 2, the temperature of the roast, this side, is 125 degrees. So at 2 hours, the roast has reached an internal temperature of 125 degrees. So we can put 125 in for the left-hand side, and we have our surrounding temperature is 350 degrees. 40 degrees is our initial temperature, and the time, this value of t in the exponent, is 2. So that's what we're going to get. And we could subtract 350 from both sides. Or actually, we can simplify this first, is what I did here. But you could also subtract 350 from both sides first. But 40 minus 350 is negative 310. And now we can subtract 350 from both sides. We get negative 225 equals negative 310, e to the negative 2k. We still want to get this e to the negative 2k by itself, so we'll divide both sides by negative 310. And a negative over a negative is positive. And while you can reduce 225 over 310, you don't have to, because we're going to be taking a logarithm anyway. So it really would be an extra step to reduce this fraction that you really don't have to do. But in any event, we do need logarithms to solve this. So if we take the natural log of both sides, because again, we have base e, so we use natural log, we'll get the natural log of 225 over 310 equals the natural log of e to the negative 2k. And as we've discussed quite a bit in the solving exponential equations, base of the logarithm, if it's the same as the base of this exponential function, this right side here is going to simplify to this negative 2k power. So copying the left side down equals just this exponent of negative 2k. So we could type natural log of 225 over 310 in our calculator and divide the result by negative 2, or multiply the result by negative a half. It's the same thing. And you should get about 0.1602. So our function as a temperature at any given moment in time, our surrounding temperature is 350. The difference between our starting temperature and our surrounding temperature is negative 310. E to the negative, here's our value of k, 0.1602 times T. So now part B, the roast is considered medium rare when its internal temperature reaches 135 degrees and is later set to rest. And it's set to rest to keep the juices from falling or flowing out as you cut it, and also it'll cook a little bit longer, not too much. It might go up like maybe 5, 10, even 15 degrees, depending on the temperature of the room you have it sitting in. But it will increase in temperature after it gets pulled out of the oven. So let's say we want to serve this thing once it reaches 135 degrees. When will the roast be done? So in other words, when will our function equal 135 degrees? So here is our function that we came up as our answer in part A. When will it equal 135 degrees? So we want to get this 350 out of here by subtracting it. So 135 minus 350 is negative 215. We can then divide both sides by negative 310. And again, if you want to, you can reduce this, but it's not necessary. We'll take the natural log of both sides since we are using base E. And the natural log of e to the negative 0.1602t is just negative 0.1602t. And then we'll take the natural log of 215 over 310 divided by this negative 0.1602, and you should get roughly about 2.28 hours. So roughly about 2.3 hours, or about 2 hours and 18 minutes after the roast was initially put inside the oven. And that kind of makes sense because after only 2 hours, it was at 125 degrees, which would be just fine for me, but I get other people would want a little bit more done than I would. So about 18 minutes later, it should be good to have an internal temperature of 135. And again, this is all under the assumption that you're not constantly opening the oven to check on it and letting the heat out and having to reheat up to the 350 degrees again. So this is why if you ever got in trouble for opening the oven a lot, it would make things take longer to cook, and this is the reason why. So I guess the wireless thermometers would be a sound investment to get this thing cooked in the 2.28 hours or so that it's going to take. All right, that about does it for this video. Thanks for watching. I'll see you next time.